Okay, in part 2 of this test review, we are going to start with number 6. So let me zoom in here. This one we have the function g of x plus 2 minus g of x. So here we're going to plug x plus 2 into the function g of x. Let me go ahead and write down g of x real quick. G of x is equal to x squared minus 4. All right, so the first thing we're going to do is we're going to plug in x squared minus 2. I'm sorry, x plus 2 here where we see x. Then once we evaluate that, or once we set that up, we're going to subtract x minus, or g of x. All right, so here's how that looks. So g of x plus 2. So we're going to do x plus 2 squared minus 4. And then we are going to subtract g of x, which again is x squared minus 4. Okay, so I plugged x squared minus 4 into g, or x plus 2 into g of x everywhere I saw x. So I need to do x plus 2 squared, and then of course minus 4, and then I subtract g of x, which is minus x squared minus 4. Okay, so the first thing is this binomial. When you do that, binomial times itself, over here you're going to end up with x squared plus 4x plus 4, and then don't forget, and then bring down your minus 4. And then here we're distributing this minus to both of these terms. So we're going to end up with minus x squared and plus 4. Okay? So now we'll start looking for some like terms. We do have the x squared and minus x squared. All right, and then we have a plus 4 and a minus 4 and another plus 4, okay? So we're going to end up with our 4x, and then everything else cancels except for the plus 4, okay? Because these canceled each other, and so did the x squared and the minus x squared. So 4x plus 4, and then all of that was actually divided by 3, okay? In the original, divided by 3. Okay. Now, we could maybe simplify this if we wanted to. We could say 4, take out the 4, and then x plus 1, and divided by 3. Okay. So our answer would be 4 times x plus 1 divided by 3. Now, as far as the domain, there are no restrictions here. We could plug in any value we want here. So in interval notation, again, it's going to be negative infinity to infinity, or to positive infinity, okay? All right, let's move on. Okay, so here on number 7, this one wants you to use the functions find f of g of negative 1, okay? So if I were to write this out, again, it's f of g of negative 1, okay? Well, you're not given a function to plug this negative 1 into, but you are given the data set with the domain and the ranges, okay? So the g of negative 1, well, when x is negative 1, here on g, you can see that the outcome is negative 2. So when we evaluate negative 1, we get negative 2. So now we are finding f of negative 2. Well, when you go up to f and you see negative 2, you see that f of negative 2 equals 3. So your answer would be 3. Okay? Number 8. Use the functions f and g to find the indicated values. Now, you may not see one that looks exactly like this, but this is f of g of 0. Okay? So we're just going to work this out in order from the inside out. So f of g of 0. Okay? Well, let's start with g of 0. G of 0. G of 0 right here is 2. So now we're finding f of g of 2. Actually, I wrote too many. F of g of 2. Well, now we find g of 2, and we see that g of 2 is 2. So now we are finding f of 2. And we know that f of 2 equals, or we look up here, and f of 2 equals negative 3. And your answer would be negative 3. So now let's look at number 9. Let me zoom in here. Using composition, determine if the following are inverses of each other. So you have your f of x, and this needs to be changed actually to g of x, okay? So we are finding, or we have two functions, f of x and g of x, okay? Now, in order for these to be inverses, we can use composition by finding f of g of x, okay? We need f of g of x to equal 0, and we need g of f of x to equal 0, okay? So what we can do, basically what we're doing is we're going to take this function g of x and plug it into f of x, and then we're going to take f of x and plug it into g of x. So let me go ahead and do that first. So let's start here. So f of g of x is going to look like this. So what we have is, so f of x is equal to 5 minus 6 times x. So this is where here we're going to plug in 1/6 times 5 minus x. So let's just write that out. 1/6 times 5 minus x. Okay, and we got to work that out. I'm going to go ahead and distribute this part first. Okay, before I distribute the minus 6, I've got to distribute this 1/6 in front of this set of parentheses. So just work that out. 5 minus 6 times, and then in here, 1/6 of 5, we could call that 5/6. And then 1/6 of negative x, we could call minus 1/6 x. Okay. Now we can distribute this minus 6 to both of these terms, okay, and keep working this out. So we would have 5, and then minus 6 times 5/6. Well, the 6's would cancel each other here, so I could just kind of show that the 6's would cancel each other, but you would have a minus 5, so minus 5, okay? And then when you do minus 6 times negative 1/6, the 6's also cancel each other out, but you have a negative times a negative, which becomes positive, and all you're left with is that x, so it would be plus x, okay? And you can see already that the 5 minus 5 would just be 0, and we are left with x. So this side equals x, okay? Now let's try the other one. So we're going to find g of f of x, which means we're going to plug 5 minus 6x in over here where we see x. So I'm just going to write all this out. I have 1/6 times 5 minus, and then in parentheses, I'm going to replace this x with 5 minus 6x. So 5 minus 6x. All right, so now what I need to do is distribute this minus sign to both of these terms, okay? So we have 1/6 times 5, and then it would be minus 5, because negative 1 or minus times 5 is minus 5. And then minus 1 times negative 6x is going to give us plus 6x, plus 6x. Well, inside the parentheses here, 5 minus 5, that we could just say cancels each other out. And what we have left is 1/6 times 6x. Okay, when we multiply 1/6 times 6, we get 1. And we have an x in here, so the answer is 1x. So you can see here that we have proven that both of these these are inverses of each other, because when we use composition, we show that they both equal x. Okay, now let's take a look at number 10. This one just says to find the inverse of f of x equals a negative 8x minus 3. So to find the inverse, we're going to set this up as an equation where f of x, which is y, equals negative 8x divided by 3. Then we're going to rewrite it as x equals negative 8y divided by 3. Okay? Now that we have switched the x and y, we need to try to solve for y. Now, the y is being multiplied by negative 8, but it's also all being divided by negative 3. So we're going to start by doing the inverse, or the opposite of dividing by negative 3, which is to multiply times 3. We have to multiply both sides times 3. The reason we do that is because the 3's cancel over here on the left, and we're just left with negative 8y equals, and on the right, we have 3 times x, which we're just going to write as 3x. Well, now we have our y over here, but it's being multiplied by negative 8. So the inverse of multiplying by negative 8 is to divide by negative 8. And we divide by negative 8. You see, this is our answer right here, 3x divided by negative 8. I'll just continue working it out. But y equals, and we have the 3x divided by the negative 8. So the inverse of x then would be equal to 3x divided by negative 8, or negative 3x over 8. All right, let's move to the next page. All right, so this one here, this one's a bit of a challenge. It says to create a table and draw the function f of x equals 1/4 x minus 3 in one color, then find its inverse, f of inverse and graph in another color. Okay, well, that's a bit of work to do on this graph. That's a little bit small, but if you will think about it, if I plug in a value for x here, such as 0, let's start with 0. 1/4 of 0 is 0, and 0 minus 3 is negative 3. So when you plug in a 0, you get a negative 3. So 0, negative 3 is on our graph here. Okay, 0, negative 3. Then an easy one to do from here then maybe would be to plug in a 4, because 1/4 of 4 is 1, and 1 minus 3 is negative 2. So I know that if I plug in a 4, I get a negative 2. So I could go over 4 and to negative 2. Okay, that's another one we could do. Or if we did negative 4, like what would happen if we plugged in negative 4? Well, 1/4 of negative 4 is negative 1. And negative 1 minus 3 is negative 4. So we would go negative 4, negative 4, and we would have a point there. So 1, 2, 3, 4, and 1, 2, 3, 4. And we would put a point right there. Okay. So you can see that we have our line shaping up here, okay, because we got negative 4, negative 4. Well, when we talk about our inverses, okay, our inverse function, well, we're just going to switch the x and y. So in our new function, we're going to have a negative 3 for the x value and a 0 for the y value. And if we have a negative 2, we get a negative 2, 4. And then if we have a negative 4, well, we could switch them, but it still ends up being negative 4, negative 4. So let me go ahead and plot these points as well. We have negative 3, 0, which would be here, negative 3, 0. And then our 4, negative 2, the inverse is negative 2, positive 4. So negative 2, positive 4 would be right here. And then this point, which is at negative 4, is still negative 4, negative 4. So we could put that point right there. Okay, then we can draw a line through that one as well. Something like that, okay? Now, on the test, you will not have to draw your own graphs like that, but I wanted you to see what it looks like to plug some values in for x and work them out. It does get a little tricky when our graphs are like this. When you're finding 1/4 of a number, we could do 8, but we don't really go out to 8 on the x-axis. So let's just go for that, and I can see that you can understand how to plug in and get outputs and then do the inverses. By the way, you are actually supposed to write the inverse function on this one. And if we did that, again, we have this inverse function. We have 1/4 x, which I'm going to write as x divided by 4 minus 3. Well, if we're working that out as an inverse, okay, first of all, we're going to switch x and y. So it's really going to be x equals y divided by 4, which is 1/4 y minus 3. We're going to end up adding 3 to the left side to cancel that. And then the y will be divided by 4, and we'd have to multiply all of this times 4. That would be the inverse function, 4 times x plus 3. Okay. Now, for the sake of time on my video, this one is just another one that's very similar, okay, where you plug in your x values and you get your y values, and then you switch the x and y values for the inverse function, okay? All right. I'm going to end this part 2 video here.